Alright, so now we're here with the congruent supplements theorem. And it's actually the same exact proof as the congruent complements theorem, but we're just talking about supplementary stuff now. So if two angles are supplementary to the same angle, then they are congruent. So basically it's saying, well, 1 and 2 add up to 180. 2 and 3 add up to 180. So 1 must be congruent to 3. That's basically all it's saying. Alright, so we're actually going to do this proof from scratch. I think you guys could do this proof by yourself already. Why? Because it's essentially just a regurgitation of what's above, except it's supplementary stuff. Alright? So what I'm just going to say is given angle 1, angle 2 are supplementary. Angle 2 and angle 3 are supplementary. And that's given. Alright, now let's use the buzzword supplementary. What do we know about supplementary? We know that supplementary means that the measure of angle 1 plus the measure of angle 2 equals 180, and that the measure of angle 2 plus the measure of angle 3 equals 180. And that's the definition of supplementary. Alright. Now let's notice we got angle 1 and angle 2 adding up to 180, angle 2 and angle 3 adding up to 180, so they equal 180, so they must equal each other. By what property? Transitive. And remember, you guys can try these proofs on your own. Pause the video, then watch it after you complete the proof, see if you did it right. Alright, now, notice how I have an angle 2 on both sides? I can eliminate it. How? Subtraction. And then last, remember, I need to end with what I'm trying to prove, and that's angle 1 is congruent to angle 3 by definition of congruence. Alright, and that's it for that proof right here. And we actually got a proof, completely different concept. We're talking about parallelograms and opposite angles, but it's really going to be mostly similar to what we just did. Alright, so we're actually going to talk about parallelograms for like a whole week, but that's going to be in the springtime. So let's just dive in and start to prove this. Alright, so we actually have a picture that we want to actually label this time. L and M. Let's just kind of do this, some chicken scratch. 180. P and O are 180. And L and O are congruent. Alright, we're going to prove that P is congruent to M. Alright, so I got my statement, I got my reasons. Let's make a 2-column proof. Very lengthy first statement. L and M are supplementary. Angle P and angle O are supplementary. Angle L is congruent to angle O. That's a given. Okay, now let's just start to use buzzwords. Supplementary, supplementary. Measure of angle L plus the measure of angle M is 180. Measure of angle P plus the measure of angle O is 180. And that's just by definition of supplementary. Okay, now they both equal 180, so you're probably saying, well, they both equal 180, so I know they're going to equal each other. transitive. Since they both equal 180, they both equal the same thing, they must equal each other. Now we're going to be very tedious right here, all right? Depending on who the teacher is, what the qualifications are, you might see this as a mandatory step, this might be an optional step, but L and O are congruent, so we can specifically say the measure of angle L equals the measure of angle O. Sometimes you'll see that because we're talking about measures, so we want to go from congruence to measures, congruence to equals. That way I can specifically, without doubt, say, well, since they equal each other, I can substitute that in right there. All right, we're being very tedious, being very thorough, but that's good because when NASA sends rocket ships to the moon, they want to be thorough. They don't want to leave any stone unturned. Or when you're making a court case or computer programming, you want to be very thorough. You don't want to have any hiccups. All right, and that's just substitution. When you replace one thing, it's substitution. All right, now notice how I have this pesky angle L on both sides. So I want to eliminate it through subtraction. So I'm left with the measure of angle M equals the measure of angle P after I subtracted it. And then I'm not quite there yet. Again, being very thorough, very tedious. Our ultimate punchline is saying, well, we need to say congruence. Angle P is congruent to angle M by definition of congruence. I could have even added a symmetric property in there. I guess I should. Let me do this really fast. Bonus step. We're not even going to... This is 6A, or 6B, I should say. Steps, as I could say. Extreme close-up. Whoa. Measure of angle P equals the measure of angle M. I could have swapped the order. Symmetric. Okay, that's me being about as thorough as humanly possible. Again, I'm a robot though, so I'm not sure what it's like to be a human. Anyways, knock out these Canvas problems. First day of angle proofs, proving some theorems to be true, becoming really smart. Good work today, students.